Hey friends, this is Module 3, Lesson 22. Today we're going to switch gears on our learning goal and take a break from division for now, and we are going to be finding factor pairs for numbers to 100 and use understanding of factors to define prime and composite. All right, we're going to get started right away. We're going to take a look at these two arrays, and we are going to write a multiplication sentence for each of them. So I feel like you guys have a pretty good understanding of arrays and how arrays are represented through multiplication sentences. So I want you to look at my screen, press pause. I want you to write down both multiplication sentences that go with each array and press play to check. All right. Did you count that there is one group of 8 in this first array? Yes, that's right, one group of 8. So it's 1 times 8 equals 8. In the second array, there are two groups of 4. Two groups of 4 looks like this. And friends, if you wrote it as 8 times 1 equals 8, that's fine. And if you wrote 4 times 2 here, that's fine. Remember, with multiplication, it doesn't matter the order that you write them in, they still make the same product. So let's talk about the word product and also the word factor. So you'll notice in the first array that we have 1 times 8, and those make 8. So in this example, the numbers 1 and 8 are factors of the product 8. So 8 is like the answer to a multiplication sentence. We call that the product. And the factors are what you multiply by each other to get that product. So let's look at the second example. Our two factors in this one, 2 times 4 equals 8. Our factors would be 2 and 4. And our product, again, is 8. Okay, so now that we know factors get multiplied times each other to make a product, we're going to go ahead and list out all the factors of 8. So 1 is a factor, 8 is a factor, 2 is a factor, and 4 is a factor. If I wanted to put those in order, I would say 1, 2, 4, and 8, because normally when we write out factors, we write them in order from least to greatest. So that's how I would write that list. Let's look at this next one. Okay, let's check out that top array and check out the bottom array. They both are making the same product actually, but I want you to write the multiplication sentences that go with each. Press pause, go ahead and do that and play to check. Okay, so in the top one, it is one group of 18 equals 18. There are 18 dots total, they're all in one row, and that makes 18. In the next one, we have two groups of 9, 2 rows with 9 dots in each, and that also makes a total of 18. So they both make the same product. So we are going to take a look at those factors. What factors do we have here? 1, 18 in that one. Those are the two factors in that sentence. And then the other one, it was 2 and 9. So if we were to list out those factors from least to greatest, it would be 1, 2, 9, and 18. Can you guys think of another way that we could represent 18 using a different array? So I want you to think, here's my little trick that I like to use. I like to see, can we build them in one row? Sure, every number can be built in one row. Can 2 be a factor of it? If so, that means there will be 2 equal groups. So what would naturally come after that? How many rows? 3 rows. Can you build 3 rows and have equal groups to make a total of 18 dots? I think we can. Yeah, 3 times 6 equals 18. So that means I've got 3 rows, 6 dots in each row, which is perfect. It makes the perfect representation, equal groups of 18. So, equal groups of 6 to make a total of 18. So we just found 2 new factors of 3 and 6. So I would have to change my factor list to 1, 2, 3, 6, 9, and 18. And here's a good way to check yourself. This is a great way to see, did I get all the factors? So watch what happens. We know that 1 times 18 are partners because they are 2 factors that make 18 when multiplied. The other partners we found were 2 and 9. They were also partners when multiplied, they make 18. And then the last set of partners, it works out perfectly, are 3 and 6. They also make 18. So we know that we're correct because every number has a partner. If you end up with one that does not have a partner, then you know there's something wrong. So let's take a look at this one. 2 times 8 equals 16. First of all, what are the factors? I want you to press pause, circle your factors, and play to check. Okay, do you have your factors? Are they 2 and 8? Great. Yes, 2 and 8 are the factors in this multiplication sentence. Good job. What other multiplication sentences could we write for 16? What else could we represent to or multiply by times each other to make 16? Oh, my favorite one is 1. 1 times anything is itself. So 1 times 16 is a super simple one. And let's see, 4 times 4. Yeah, I also love that one because I love anything multiplied by itself as well. Those are the only factors of 16. So if I were to list them out, it would be in order 1, 2, 4, 8, and 16. Now let's check and see if they all have partners. That's right, 1 times 16 makes 16. 2 times 8 makes 16. Now, why does 4 not have a partner? Oh, because it was 4 times itself. So we're not going to write 4, 4. We're not going to write it twice. We just understand that 4 is its own partner in this case. So that's kind of a tricky one that you need to understand that sometimes you can multiply a digit by itself and it gives you the same product that you're looking for. All right, let's check this one out. 1 times 7 equals 7. Okay, so what are the factors in this one? 1 and 7. Okay, I want you guys to find another factor pair that you can multiply by each other that makes 7. I want you to think about that. Are there any? Nope, 1 and 7 are the only factors of 7. So friends, we have a special word for this, a special title that we give to these types of numbers that only have 1 and themselves as a factor. We call them prime. So down here in the corner, you'll see this handy little poster that reminds you that prime means that they only have 2 factors, 1 and itself. Like the number 2 is a prime number because 1 and 2 are the only 2 factors that make 2. 3 is another example because 1 times 3 is the only way that you can multiply to get 3. 5 is the same way. 1 times 5 is the only way to get 5 as a product. 1 times 7 is the same thing. 1 times 11. Friends, there's lots of other prime numbers, but I just want you to understand that prime means that it only has 2 factors, being 1 and itself. Okay, 0 and 1 do not count as prime. They're neither prime and they aren't the other word which I'm going to talk about, which is composite. So in all the previous examples that we just did, they were all composite because they had much more than 2 factors. Some of them had like 6 factors, and there could be many that have many, many more than that. If it has more than 2 factors, being just 1 in itself, if it's got more than that, we call it composite. All right, so let's take a look at these 3 numbers, these 3 amounts that are being represented. We're going to find the factors for each number, and then we're going to decide if it's prime or composite. So friends, I want you to start on your own. Actually, no, I don't. I'm going to show you my example first for 23. Are you ready? I'm going to show you my chart for 23. This is what I came up with. Factor pairs for 23 is 1 and 23. I tried 2, I tried 3, I tried 4. Nothing partnered with any of those numbers to make 23 as a product. So, friends, what would we call this? Prime or composite? Did you say prime? Nice job. Okay, now it's your turn. I want you to take a look at 35, and you're going to make a table just like I did here. This is a table, and I have listed all the partner pairs for 23. You're going to do the same for 35. I want you to press pause, make your quick little chart of that, and press play to check. All right, here we go. Let's check. Find your table, check it with mine. Okay. So not very many more factors for 35 than we had for 23, but does it have more than 2 factors? Yes, it does. It has 1 times 35, that's my favorite, 5 times 7. Okay, so is this prime or composite? Composite, that's right. It has more than 2 factors, so it is composite. Good job. Last, friends, is 48. So I'm going to clear all this out because 48 is a much bigger number, and I'm just guessing it's going to have a couple factors. So I want you to press pause, write out your own table and as many factors as you can find for 48. Remember, factors should have partners, and press play to check. Okay, so here we go. Oh my gosh, did yours match mine or did you miss a couple? Here's a good way to check, friends. So we like to see, and I color coded mine, so all the partner pairs have their own color with their partner. 1 times 48 is 48, 2 times 24 is 48, 3 times 16 is 48, 4 times 12 is 48, and 6 times 8. Now, friends, I knew to stop here. Do you know how I knew to stop here? Because if I added one more partner pair, I would have ended up going up to the number 8. 8 would have been this factor right here, and 8 times 6 is 48. And guess what? I already have 6 and 8. So I don't need to start the list all over again. Once I have a partner for 8, it's a partner no matter where I put it. If it's on this side or this side, it's always a partner. Okay, so 48 is definitely composite for sure. It's got a ton of factors. Okay. This is your multiplication chart that I want you guys to use if you're struggling with finding factors of numbers. So this is included in your student slides that you have, and you can also use the tiles to help cover like we've used in the past and past lessons. So please don't be afraid to use your multiplication chart for now. If you need it, use it. It is a helpful tool so that you can look and find, oh, there is 40 there, and oh, is 40 another product of something else? Yes, it is, right? So like 40 is 8 times 5 makes 40, and 4 times 10 makes 40, and where else do you see 40 on your chart? Oh gosh, 10 and 4. Oh, yep, we've already got 10 and 4. Okay, so that's a good example of using that to help you with your factors and products. Okay, our learning goal today was I can find factor pairs for numbers to 100 and use understanding of factors to define prime and composite. Awesome job today, friends. See you in the next lesson.